Hi guys, and welcome back on my channel. In this video I'm going to show you how to create a Light Studio group node in Geometry Node to speed up your project. It can be used to debug a simple scene or to create a more complex and animated environment. So let's get started. I'm working with the Blender version 4.1.0 and the goal of this is to create a simple shape like a mesh. So Shift A to add a mesh plane. We can go on the plus menu here, General Geometry Nodes, and create with this click the new Geometry Nodes system of our Lights Studio. I thought to allow you to be able to choose 4 types of instancing of the lights on particular shape to cover many cases about light environment. So first of all, we are going to create a new menu switch in our setup to create with N and going in the node zone the items we want to choose to instantiate our lights. So I'm going to create here the grid method, the dome, very useful to simulate an HDR lighting. Then we are going to create an arc method and finally a mesh, so a custom mesh shape to instantiate our lights. So to use the light, I'm going to create a new collection because I want to let you choose a set of lights if you need, and not only one light in your environment. So we can call it light sources. We can drag the default light of the scene inside this collection and, for example, choose area type and choosing the shape as a disk. We can increase the size a little bit, like 1 meter, so we can see the disk of the light. Next, choosing the plane, we can rename it in Lights Studio. Go in the modifier, change the name in Light Studio. We can export these menu switch inside our group input, and we can add another node in our group for our collection of lights. In this case, we can rename it in lights and rename this menu in method. I can choose from these lights the collection of the light sources I want to use to instantiate them on our mesh. So first method to instantiate our lights, we can create a grid. We can export the size on the X and Y, the number of vertices in our group node. We can add a useful panel, rename it in grid, and dragging all the parameters of our grid to better structure our group node in the stack modifier. We can rename it in width, length, width count, and length count, so the number of vertices of our grid. In this way, I can drag this mesh in a instance on point node, and because we have a collection here, we can drag this light here and select the automatic item collection info collection like this, checking these separated children because we don't want to use all the light sources as one single object or instance, but we want to use them separately. In this way, we can link the instances inside our instance on point, link these instances as the output of our grid and the output of this menu switch in this geometry, and this is the result. As you can see, we have the light sources instantiated on our grid with this strange rotation, so we need to select our original light and press Alt R to reset all the rotation in all these 3 axes of this light. And why this? Because we want to be able to rotate each of these light, so the Z direction of the original light, that is this, following the normal of the vertices or the faces of our mesh on which we have instantiated the collection of the lights. So to do this, we need to use this rotation, but because we have here a grid, so we need to use the normal of our vertices or faces. We need 2 other things. One is the choice of the sources points on which we want to instantiate the lights, and for this I'm going to add here a new input like sources, and this is a new menu, so we can press F3, menu switch another time to create a new menu and link these input inside these sources and change for this node the vertices or the faces of our mesh. The second part we need to add is the information of the points of these vertices and faces, and I can link directly the mesh inside the vertices and use the mesh to points to get the information of the faces of the grid. But before this, I'm going to save the information of the normal of our vertices and faces. So to do this, we can add a store name attribute. We can link the grid because we want to save the information of the vector of the normal of our points based by a name, a common name, a shared variable we want to use for the entire geometry nodes setup. So for this reason, I'm going to create a string to set a name of my normal variable. I need to use here in this store name attribute. I'm going to duplicate with a Shift D this store name attribute, linking the same grid, but in this case storing the information inside the face domain using the same name of the variable and the normal information inside. Why this technique? Because next we are going to take from this output the information stored inside this variable using this menu switch, and because we can't pass through this menu switch the information of the stored variable, we can read this information after this output that will contain the correct points we need to use inside this instance on points node. In this way we can link directly these vertices because this vertices menu is dedicated to the points information of the grid, but in this case we stored the information inside the face, but from this output we would always get the information about the points of our mesh. And to be able to export the information about the faces of this mesh, we need to drag these in a mesh to point node to export from this node the points of the faces and not the vertices of our input. So don't be confused by this node that is indicating here face. Okay, this node only saves the information about the normal of the faces of the mesh, but from this output here we have points or vertices in this case because we have a mesh. So now we can drag these points in these faces and use this output as the input points for our instance on point. It's obvious we have nothing because we have no sources selected here, so we can go inside the group node and set the default to vertices and set a single value, the same for the method and the default to grid. We can choose vertices, and as you can see now I have the lights instantiated on the vertices of my mesh of my grid, but if I choose the face we have only the lights on the faces. I can make this setup better. For example, I can separate and duplicate this group input to link the collection inside the collection info here and move these a little bit to separate the nodes about the instancing operation, then the other nodes of the setup. The same for the method, so I can separate this group node and link the method inside the menu and leave these apart. And finally the same for the sources menu, so linking here these in this way so we can have a better layout. Let's add the scale information about the instancing operation, and for this reason we can drag this scale inside the group node here and change these from a vector to a float number, selecting the single value here from 0, default to 1. In this way we can scale our lights, but keep in mind in this way I have a problem about the scale. Why? Because my original scale in the collection of the light sources has a different location than the global origin point, so I need to reset the location as well as the rotation. And to do this we can select the light or the lights inside this collection and press Alt G to set 0, 0 and 0. Now we have the original grid here and the instantiated lights on the sources we set here. We can hide the light inside this light source. We can increase a little bit the sizes of our grid, like this. Now let's fix the rotation, and to fix the rotation we are going to use the previous saved information of the normal. So I can add with F3 the name attribute, read name attribute, set here the v normal, and link this where in the align Euler to vector in the vector socket, because we want to align what? The z-axis of the original light of our light sources collection. In what direction? In the direction of this vector with the maximum factor. So the vector is this normal, and we can link this in this instance on points. You don't see anything because the direction in this moment of the normal of these information points are pointing down, but we will see in the other method, so the dome or the arc or the custom mesh, the visible effect of this alignment operation. As you can see, I can increase or decrease the number of the vertices in one direction and the other direction. So now I'm going to select the vertices because I want to add another attribute here, that is the cover parameter. So I want to be able to enable or disable, if you want, the lights in one direction. In the case of the grid, the X direction. So if you want to use the Y, it's the same. You just rotate the object, the entire object, by 90 degrees on the Z-axis to have the Y direction instead the X direction. But as a default, I'm going to use the X-axis. So to do this, we need to use this selection socket, filtering what? So in this case, we need to calculate from our grid the bounding box of the entire object and use the maximum and the minimum values of the X as a ramp from 0 to 1, and use the new parameter from 0 to 1 as a range value, where if the position of our lights, of our points, are below this new cover parameter value, we want to maintain and select those points to instantiate our lights. So to do this, we need to go here in the output of this menu switch, drag this in a bounding box geometry, because we want the entire bounding box of our mesh, and this will be similar for our dome effect. And from this we want to take the maximum and separate the 3 axis components, the same for the min points, so the minimum points on the space, in this case looking the axis of our environment, this is the maximum point and this is the minimum point, and we can separate the components of these two values, getting the x-axis for both of them. In this way we can take this minimum x and this maximum x, and from these we can go inside a map range node, linking what? Linking this value of the minimum x in this minimum of the output of the map range, because what we need is to create the cover parameter, that is a value from 0 to 1, so 0 no lights, 1 all the lights on the mesh, and we want to transform the range between 0 and 1 to the minimum and maximum value of the real x in the space. Keep in mind these information are about the local coordinate system of the object, so in this way if I rotate these, the system will calculate the x information in this direction, because I rotated the entire coordinate system of the object of the mesh. So we can go inside our group node here, and after this length count for our grid, we can add a new value of input as a float number, subtype factor with a default of 1, for example, from 0 to 1 as the maximum value, selecting the single value here and rename it in cover. We can set 1 for now. Now we can duplicate this group node another time, linking this cover value inside this map range, and now we can take the position of our points, because this information comes from this output here. Okay, so if this position separated with its components and in detail the X component is less or equal the output of this cover information, we want to use this result as the selection of our points inside this instance on point. Now, if I decrease the cover, as you can see, we have this result. And as you can see, if I have a 0 cover, we have here less than or equal. So if I select the less, I lose all this information. Otherwise, I can use these to cover all. But as you can see, we have the problem of the entire covering or the entire disappearing of the components. So to fix this problem, we can easily change the less than or equal to get the complete coverage of the points. And if we have the value of 0, so the minimum value, we can ask this condition to get 0 points selection. So if this map range output, so this result, is equal exactly to the minimum X of the bounding box, and this means that the input value of this map range is exactly 0, so the 0 cover, we can use this in a switch, selecting the type in Boolean, and if this is true with no epsilon, we don't want any selection of the points. Otherwise, we want to use the previous result of the less than or equal. In this way, if I link this output in this selection, only in the case of a 0 cover we have no selection. Otherwise, all the values less than or equal the value of the X selected from the map range, we show the correct points on our mesh, as you can see, up to 1, so the maximum value of the bounding box. We can use the G shortcut to make this a little better, like this. Now we can add 3 additional parameters to cover all the cases of the methods of our group node setup, and they are the flipped direction of the normal. If you want to instantiate flipping the direction of the lights, it's obvious it's useful with area lights, spots or sun type of lights, and not points. So we can go here in the group node, add a new input, and this is the flipped direction. It's a type Boolean, single value, default to false, and the other 2 parameters, so the custom focus of all the lights on a custom object, because in some cases you want to use this setup to instantiate in the correct position of the space the lights, but maybe you want to let them focus and follow a custom object, an empty or whatever. So to do this, we need to click here to duplicate the item of the flipped. We can rename it in custom focus and add another parameter that is an object type, that is our focus object. That can be whatever object you need inside your scene, an empty, a mesh, a curve, or whatever. So in this way, inside the rotation, we can drag the flipped socket in a switch menu, selecting here the float value, because if we want to flip the direction of the normal, we need to multiply the scale, the normal vector, by -1, otherwise by 1, to remain the same. So in this way, I can take this normal information and drag it in a scale group, linking this float as the scale of this vector to get the correct opposite direction of the normal. Now I can take this output and link this to the vector of this alignment, and in this way I can flip in a correct way the attribute of my normal. We can move this a little bit, and this is the flip operation. Now let's manage the custom focus and the focus object. So in this case, we can take the information of our focus object, like this, leaving the relative selection, because I need to know the correct and real-time position and location of my object selected. And for this, I'm going to create with the Shift A a new monkey object. Keep in mind, make attention in the making of this object, because in this case I made a mistake, because Suzanne is inside the light source collection and I need to drag out from that collection. I can move it a little bit, and now we need to calculate the vector from each point of our mesh and the location of our custom object. And to do this, it's not so hard because we have the location of our object and the position of our points. So if I want a vector from this point to the monkey or this point to the monkey, we always know that we need to make a difference between two vectors. One is the vector of the position of the monkey and subtract what? The vector of the position of our points. In this way, from this position, subtracting the position of the points, we get the different vector between these two vectors, because this plus this vector is equal to the vector of the location of the monkey. So in this way we can take the location of the object and from this location subtract the position of each point on which we want to instantiate the lights. Keep in mind here we have not a single number but a number per point. Okay, so the value of the location is shared between all these points, but here we have an array, a set of different positions. So in this way, from here we have the correct direction, and from this I need to have a better layout. I need to normalize the vector to have an entire length of 1 for this vector, because the position vector can be greater than 1 in the length. And then we can link this custom focus in a new switch node, selecting here the vector, because if we don't want to use the custom focus, so this value is false, we need to use the output of our normal, so the standard behavior. Otherwise we need to use this new direction and not the normal. So this is the normal, but this is the direction through the monkey, and from this output I need to scale looking the new flipped parameter to have the same direction or the opposite direction. Now I can use the H to collapse a little bit these nodes like this, and as you can see now, if I set flipped, I have the opposite direction of all the normals of my vertices or faces. Okay, this works perfectly. And if I select the custom focus, as you can see, we need to select what is the destination object. In this case I select the Suzanne, and if I check or uncheck the flip direction, I have the opposite direction, and I can select the Suzanne and move inside my space, and all the lights will follow the Suzanne position. We can select the preview material like this, setting here in this preview the scene lights, because I want to use the scene lights. We can decrease a little bit the power of this single light as 100 watts, and because we are going to use the entire information of instancing behavior not only for this method of grid but also for the dome, the arc or the mesh, we can make a group for these nodes, selecting them and pressing Ctrl G to create a group. And because we need to reuse the same string of this variable inside other cases, other methods, we can drag this name out in this group node, move it up a little bit, move the other parameters where we want, like this. We can re-change the scale from a vector to a float value, like this, rename the flipped attribute, the custom focus and the focus object, move the scale under the name and move the collection up a little bit like this, move it a little bit here, press H to this name attribute to collapse a little bit the entire group node, and this is the final group node of instancing operation. We can go out from this group node, clicking here to the parent node 3, and we have the instancing node that we can call instantiate light. For the same reason, I can link this string v normal inside this name attribute to don't set manually, and we can move these two nodes a little bit here. Now this entire workflow is about the grid, but the dome is similar because instead of using the grid, we will use an icosphere. So we can select all these nodes, holding Shift, also these and these, press Ctrl H to collapse, showing only the used attribute. Now I can select all these nodes here, press Ctrl J, F2, grid for the grid method, and now we can take all these nodes, Shift D to duplicate them and click, and as you can see we have a problem. Blender cannot allow you to have more than one node for the same menu switch definition. So if you have this need, you need to take the menu switch and press Ctrl G to make a group, and you can have multiple groups related to the same single definition of the menu switch. So in this way I can go inside this group node, choosing the group menu and rename these in points, because we could use points of control points of curves instead of mesh. Go up from this group node, and then in the previous original frame we needed to replace this menu switch with the new group node. So we can rename it in Lights Sources. We can duplicate with the Shift D, Alt P to exit from this section, and go inside this section here. Go here, link the same input inside our new group node object, link the sources, delete this root, and then link this output to the bounding box and to this output here. In this way I can delete this menu switch that is inside this group node. It's the same, and now all works like a charm with this new connection. In this new duplicated part we can rename the grid in dome, and instead of using another duplication of the string, we can use the same variable inside this and inside this store name attribute. You could create other group nodes if you want, doesn't matter. And now instead of using a grid, I need to use with F3 an icosphere, linking this mesh inside this geometry here and here, dropping this grid. Now I can expand this group input with Ctrl H because I want to drag the radius and the subdivision of this icosphere, creating a new panel inside my group node, and I want to go down under the grid, rename it in dome for this new panel, drag the radius inside, drag the subdivision inside and under the radius. And also in this case I want to create a similar cover variable. You could probably use the same cover as a general parameter for all these two methods, but I decided to use one for each method. In this way I can select the cover item, duplicate it and drag inside this dome under the subdivisions. And for this reason I need to link the correct cover variable inside this section. That is not the previous cover of the grid, but the new cover of the dome. And instead of using the X, I want to use the Z value because it is more common in a standard environment have the dome of the horizon and the sky, for example. So we want to use the Z axis to get the correct selection of points between up and down or down and up. Or for example, if you have a lamp in a room that is a spherical or semi-spherical shape, maybe you want to use the same approach. So in this case I will use the Z position for the mean and for the maximum, and the same Z for the limit for the correct selection of the points. And in this case we needed to duplicate the instantiating node with the Shift and D, linking the correct information like the name of the attribute for the normal from the previous common and shared variable, link the output of the chosen point inside our points on which we want to instantiate the lights, and link this output inside the general menu for the DOM result. In this way, I can disable for a moment the custom focus, go in the item section and reset for a moment the rotation, disable the flipped variable and select not the grid but the dome. And as you can see, have an icosphere that I can increase with the radius like this. Don't be scared about the direction of the light. The lights are pointing in this moment inside the object, so in the center of the icosphere, because the normal is through the center of the object. But because we have also the lights in the opposite direction, you see these overlapping lines. So this line here goes in this direction and this line here goes in this direction, okay, for this light. If I flip all the lights, as you can see, we have the lights outwards. If I unflip, I have this result here. And now I can select the correct points on our icosphere. And now, before using and tweaking the cover parameter, we need to use the same Z information also from this separated position. And now, if I increase the subdivision of my sphere like this and enable for a moment the flipped parameter, if I decrease the cover, as you can see, I have this behavior here, and this is correct. Now, if you want to use these like 0.5 to have the semisphere result as the lights, and you need to have the opposite result, the opposite effect, you just need to rotate the object by the Y, for example, by 180 degrees, and voila, you can enable the flipped operation and you have a classic dome lights environment. The same behavior for the selecting of the custom focus. If I enable these, all the lights are pointing outwards from the direction result of the vector pointing through the monkey. So if I flip the direction, all the dome lights will point through the monkey. And this was the dome effect. Another method is more simple, and this is the arc. And to do this, we can easily duplicate the instantiate light group node as before, Shift D and duplicate. And instead of using the exact duplication of all these nodes, we can use less nodes. And first of all, we need to add another panel inside our group node. So I'm going to use another plus panel like this, rename it in arc, and moving these down under the dome. Now we can create an arc curve, and this is very useful when you want the classic 3 lights studio environment. So we can add the group input node because we need to export what? The resolution, the radius, the sweep angle, because I will need to create a single piece of arc and not the entire circle curve. We can drag all these nodes inside our arc panel for the radius, the resolution and the sweep angle. We can rename the resolution in points, so the number of the control points of our curve to instantiate the lights. So as you can see, we have a little problem here. If I link this curve to these points and use these output in the arc menu, the general arc menu, and select the arc like this, I disable for a moment the flipped and the custom focus. As you can see, we have this behavior. Now I'm going to decrease the number of the points like 3 and increase the radius like this. And instead of using the sweep angle in decrease, we can use a factor from 0 to 1. So inside this our group node, inside the sweep angle, we can use a subtype of factor from 0 to 1. Set 0 for a moment, and keep in mind here we can't use directly the sweep angle inside this arc, but we need to drag this sweep angle in a map range because we need to transform the range between 0 and 1 to 0 and the maximum 1 round to have the perfect arc as a circle curve. So because as a default behavior the sweep angle works in degrees, but if you link other output from other nodes like these it starts to work in radians, you need to convert this output in radians between connect these two elements. So to do this, we need to go here and set 2 multiplied by pi, so 1 round. If you don't remember this value, 6.283 or 2 multiplied by pi, you can use the value node set inside 360 and drag this value in a 2 radiant node and then link this value inside the map range. This will automatically convert this value from degrees in radians. And then we can use this result as the sweep angle. Now I can increase this value from 0 to 1, but as you can see, we have a problem. If I have 3 points and use the maximum sweep angle, so the entire round, you can see the last point, goes to the final part of the entire arc. So if for a moment I press Shift, Alt and click to see the arc, this is the arc made by 3 only points inside, as you can see here. And if I increase or decrease this sweep angle, I have this problem. So how can I distribute in a perfect way these 3 points in the space to have the same distance between them? I should set here the correct and perfect number to have the perfect distances. And this is very hard to do, but keep in mind this simple equation. If I have 3 points and I decrease this value like this, for example, if we press 7, I have the same distance between these points or these future lights. So if I set here 4 points, I need to increase this value to have this distribution. And as you can see, this value is always the number of points minus 1 divided by the points itself. So to distribute 3 points, I need to have 360 degrees divided by 3 to have 1 divided by 3 here, 1 divided by 3 here, and 1 divided by 3 here. So 2 divided by 3 equal to 0.666. As you can see, if I divide this factor in 3 pieces, I have 1 piece, 1 piece, and a third piece. And this is the general formula. So if I have 4 points and I want to have the same distance, I can divide 3 by 4 and have the correct distribution. So instead of manually set this value all the time when I want to automatically distribute these points in the space, I can add a simple parameter that can do this for me. So I can go inside my group node, add a simple input as the auto distribution of my points in this arc. I can drag these inside this section, change the type in Boolean, and in this way, if I check the single value and check this auto distribution, I want the system auto calculate the correct sweep angle to have the same distances between all the points of my curve. If I don't use this auto distribution, I decided to use the sweep angle to distribute the lights in a particular way around the object and following the direction of the making of the arc. Okay, so in this way you have both of these techniques. So now that we have this auto distribution, we can link this auto distribution in a switch node, selecting here the float value because we need to calculate the correct sweep angle output to link it inside this map range. So I can link this value here, and if I don't want to use the auto distribution, I want to use the original sweep angle manually set here like this. Okay, so if I set 8 point and I want to have the lights near in this way, I can do it, setting for example 0.5 to have this perfect distribution. But if I want to use the auto distribution, I need to take the number of the points, subtract 1. So if I have for example 3, I need to do 3 minus 1 divided by the number of the points itself and use these in this true of the switch. In this way, if I set auto distribution, I have the perfect distribution of the distances. If I increase this number, I have the correct distribution. So now we have a last issue here. You can see we have the control points distributed in the space, but as you can see, the normal of these points are different than the vertices of the previous meshes. So in this case, the normal of these are correct, these points are correct, but the normal of these 2 points are not correct. And I can prove you, because if I link this result inside this group node and I store the same information of the normal inside the control points, so adding with the F3 the store name attribute inside this control point, selecting the vector of the normal and setting the same name of the attribute as the other method, so the v underscore normal, to let the instantiate light use this attribute to rotate in the correct way the points. As you can see, we have the correct normals for all these control points, but the last and the first. So to solve this problem, we easily convert this curve to a mesh to have vertices and link these vertices inside this store name attribute. Now the last important issue is this: if I disable the auto distribution, maybe you don't see it, but if I increase this value and go to the maximum value of the factor to distribute in this way the value, maybe you don't see, but here we have 2 lights overlapped to themselves. If I decrease a little bit, you can see this overlapping. So to avoid this behavior, we can easily add between these 2 nodes a merge by distance node, decrease the distance to 0.0001, for example. And now if I increase to 1 this vector, I have not 2 lights here, but only 1. And I can prove you if I go here and press Ctrl Shift and click on this curve to mesh, we have 8 vertices, 1, 2, 3, 4, 5, 6, 7, 8, 2 overlapped, and after this node I have only 7 vertices. I increased a little bit this distance to have this result. I drop this viewer and now I have the correct number and distribution of my lights. For the same reason, I need to connect the same attribute inside these instantiate lights. Even if I have the same correct value here set manually, I can use the H to collapse some nodes like this and create some route to connect the attribute inside my instantiate light group node. I can move this a little bit. We can select all these nodes, Ctrl J F2 arc, and in this way with the arc we can easily change the number of the points of the lights, change the radius, change the sweep angle, auto distribute these points, and use, it's obvious, the flipped direction, as you can see here, or the custom focus on the Suzanne. Last type is the mesh. So for example, if I go in the edit mode of my mesh and select all the points, scale up a little bit like this, I can use this mesh as the component for instantiate the lights. So if I want the face or the vertices, for example, if I press 2 and select this edge and extrude to the Z down, I have 2 faces, okay? And now if I select here the method of mesh, I can duplicate the entire workflow of the grid. For example, pressing Shift D and moving down here, I can go in the grid section, press F2 and set mesh. We can delete all the cover information to select our point, because I want to use my mesh, my custom mesh, to instantiate the lights, so I can delete all these notes about the selection. I can duplicate this instantiate light node, link the same information of the attribute v underscore normal to save the normal in the points and in the face of our geometry, our custom geometry, like this, and I can delete this. I can expand this group input and use not the grid but the geometry itself inside my store name attribute, like this, I can drop this grid and I can use this output directly in the points of my instantiate light and use the same name for the attribute here, no selection, here in this group node, and then link this output to this node in the mesh operation. And as you can see, I have all these instantiated lights. If I go out from this edit menu, you can see the result. I can select the faces instead the vertices, and as always I can flip the direction of the normal and use the custom focus on my monkey. And this is the example of the custom mesh. Now I can select this group node, go to the select group it by the type, and Blender will select all the group node input, press Ctrl H to expand all the sockets and press again to collapse all the unused sockets. In this way you are free to, for example, make this funny example. You can create with the Shift A monkey of lights and disable the custom focus and use a monkey of lights to illuminate what you want. And as you saw in the intro video, use this technique to create your dome light or studio light. For example, if I select the arc and auto distribute 3 points on the space and use this flipped, I select this monkey, Alt G, and voila, I have the 3 studio lights environment. You can use different lights inside your collection. So for example, I have a light here, and if I add another light as a spotlight, as you can see, the system will instantiate both of these objects. Why this? Because in our lights environment, inside this instantiate light group, where there is the instance on points node, you need to check the peak instance, and in this way the system will automatically choose and loop the object from this collection to instantiate the lights on your point. So for example, I can see here we could have 0 index, 1 index, 2 index, 0 index, 1 index, 2 index. And as you can see, Blender repeats the area lights in the first and the third index of this arc, and this can let you create a different light, for example based by a random color, as you would see in my file if you download it, because I set a random light, one for each light instantiated on the mesh. So you can use different characteristics inside your collection, or you can use only one light and manage the shading of the lights inside the shading editor to manipulate the color, the intensity, the texture, and whatever. Another funny way is to create, for example, a geometry node system that delete random points of your custom shape before this group node. So in this way you can have lights distributed on a random position in the space, because you are using a custom shape. So I remember you to include this group node inside your blend file. You can press file and create a new file, or open your project and use the menu link or append, selecting my file from Gumroad, selecting the subfolder node 3 and selecting the group node named Lights Studio. Or you can create it from scratch. Thank you guys for watching this video. I hope you like it and learned something from it. You can always download this project file as the intro file from my Gumroad page. If you like my work, please subscribe to my channel and don't forget to check the bell icon to get all the notifications of my new videos, and see you to the next tutorial. Bye!